Welcome back again. This is Wi-Fi Tech Lab channel. We're just gonna go to a basic simple lab about Cisco IP phones. This is the main topic based on CCNA, so we're just gonna keep it simple for everyone to understand, especially for the ones who are actually new onto network configuration. We're just gonna design a simple lab of one router with one switch and maybe 4 phones connected to 4 PCs. Let's do it quickly without wasting time. I'm just gonna place 4 phones on this side, 4 PCs, and then I'm gonna place another 4 PCs on the other side as well. Remember, we said we're gonna use our IP phones to be directly connected to these PCs in here. In that case, I'm just gonna navigate again using something called Cisco Packet Tracer. You can actually download it on Cisco website. I'm just gonna use these IP phones, and then I'll have to select one switch that I can use. In this case, I'm just gonna keep it real with 2960. Let's go to the router that supports the telephone service. In this case, we have to select 2811. On the Cisco Packet Tracer, 2611 is the one that is actually functional with telephone services. I'm just gonna try to use the cables in between to connect all of these devices. To actually do that, I have to go to this and then select the straight through cable. I'm gonna use fastnet 0/0 to connect to fast 01 on the switch. Same thing applies with the first phone. I'm gonna use switch into fast 2. I'm gonna use one cable that's gonna go to fast 3. Same thing applies, it's gonna go to fast 4. Let's have another cable that's gonna go to fast 5. Now let's go to the other end. We have fast 6 connecting to the IP phone, and then with fast 7 all the way to fast 10, all the way to fast 9. Alright, now let's try to connect our PCs to our phones, because we are trying to allow the data VLAN to actually give out the IP addresses to these end host devices, while these devices are actually connected to these IP phones. So we will have to have a cable that comes from the switch, which goes to the phone, and then from the back side of the phone itself, the one port that allows us to connect a PC. In that case, let me try to show it to you. As you can see, we have this port where we can actually use a cable that is connecting to the PC. It's 10 to 100 link, so we're just gonna plug in our cable in here, and then we have this port in here dedicated to go to a switch, which is this is the cable that we're talking about. I'm just gonna do that right now. This is going to the PC. Same thing applies with the rest of these phones. They all gonna go to fast 0. This is the network interface card of the end host device. Could be a Windows PC, or it could be a Linux. Let's do the same thing here. Let's do the same thing again here on that PC, then let's get over to last PC and do the same thing. Okay, now we have actually tried to design our simple lab. This lab is gonna be more focused on IP phones, Cisco IP phones config, and then also it will have some feature of a DHCP. It will have some feature of something called on-stick routing. Okay, so this lab itself alone is gonna touch based on these topics: Cisco IP phones configuration. It's gonna touch upon how to configure DHCP and also how to configure on-stick routing. We're just gonna try and use simple class C IP addressing 192.168, let's say 20.0/24. This is the network ID that we're going to use for VLAN 20, and then let's create another one which is going to be 192.168.10.0/24. This is a network ID that we're going to use for VLAN 10 as well. I'm just going to try to create this so that people will be able to see that we're actually trying to use that IP address with these VLAN IDs. So we're going to use VLAN 10 for 192.168.10.0/24, and I'm going to use VLAN 20 for 192.168.20.0/24. Alright, now we can start our configuration. First thing that we have to try and do is to make sure that we start on our router up there. Let's click on the router and try to enable the router by going to enable. This is a privilege mode where we actually see the configuration that are currently running on the router, but we're trying to configure the router, so we have to navigate to the global config mode by typing the command config terminal. Let's change the host name and call it maybe R1. Host name R1. Alright, as you can see, this is the host name that we have now. Remember what we said. We actually said that we gonna touch upon these topics, which is Cisco IP phone configuration, DHCP, and on-stick routing. In this case, let's try to start with something called on-stick routing. We are trying to allocate the IP addresses to the correct VLAN. By doing that, we're gonna create something called sub interfaces on that interface, which is FA0/0. First thing first, let's get on and switch on that interface. We're gonna start by selecting the interface, which is interface FA0/0. If you look on this router one, this is the interface that we're talking about. So we're gonna go into it, and then we're just gonna hook it up by typing command no shutdown. As you can see, the status have changed from red into green, which indicate that this interface is now up. By default, on each and every router we have to actually hook our interfaces up. As you can see, the line protocol on the interface 50/0 changed status to up. Now what left to do is we have to navigate to something called sub interfaces. That's where we're going to encapsulate .1Q tag of our VLAN. So basically what we have to do, we have to select the same interface, which is 0/0, but in this case we have to use the sub interface of that interface, in which we have to access it by typing this. As you can see, the status have changed to down, and then also this interface have changed to up, in which it's a fast 0/0, but if you notice, we have a .10. So now we actually have to, as you can see, we are currently on a config sub interface mode. So now we have to type the command encapsulation.1Q tag, and we have to specify the VLAN that we're actually trying to configure, and therefore we can carry on assigning the IP addresses of this VLAN. In this case, we have said that we're going to allow VLAN 10 to be configured 192.168.10.0/24. We're going to choose any first usable IP addresses on this subnet. In that case, we're going to use 1. It could be 2, it could be 3, whatever IP that you can choose on the same pool. In that case, I'm just going to use 1, and then I need to specify the subnet mask of this class. In this case, this is a class C. We all know it have 255.255.255.0, and then by default, this interface, as you can see, the status is actually up, but it's a good practice to always just say no shutdown, just in case. Alright, and we have actually configured the something called sub on-stick routing, or the sub interfaces. So all we have to do now, we have to do the same thing for that VLAN, which is VLAN 20, because we are trying to allow these to be data VLAN. And then we are actually trying to make this one to be traffic related to voice. What does that symbol mean? It means if the computer or any other devices except the phone, if it get connected on the same port, it will get the IP range of 192.168.10.0 subnet. However, if it's a voice related traffic or device, it will get the IP address which start from 192.168.20. I hope that makes sense. Now let's get back to it. Now we have to go back to the interface itself and say interface fast 0/0.20 again to allow us to go to sub interface configuration, and then from there we can actually further type that command encapsulation.1q tag, and then this time around we're gonna say 20 because we are trying to assign that IP address IP at 192.168.20.1, and then remember this is class C, so we're gonna use that subnet mask, and then we're just gonna say no shut, and then let's just exit. Even though the sub interface is by default, as soon as you enter to its mode it just changes it as to up, but it's a good practice again. Okay, now we have actually done with the on-stick routing. All we have to do now is to come back here on the DHCP to make sure that the devices automatically get assigned with the correct IP addresses related to that VLAN. In that case, how to configure, we have to make sure that we are on a global config mode, as you can see, and if I press the question mark, you will see that there is an option to configure an IP over here. In that case, I will use that option by typing IP, and then I will have to select something called DHCP pool. I can then further enter any name or any alias name that will make sense to make me understand this configuration is actually related to that alias name. In that case, let me make it to be simple as, let's start with data. For instance, I'm just gonna say this is a data net. All right, and then on this is just the name, it doesn't mean anything, it could be any or your preference name. So let's just add something called a network in here, 192.168.10.0 255.255.255.0. This is our network that we'll be using on this DHCP pool. And then if we go to the default router, that is our default gateway in which all of the devices will actually use when they are getting the IP address that belongs to this network ID. So let's make it 192.168.10.1, and then our DNS server. If of course we have a DNS server this is actually configured on your network, you can actually use the IP address. In this case, I'm gonna point it back to 10.1. However, you can also add another one if you want to, but I'm just gonna use this one for now, which is 192.168.10.1. all right, if you pay attention, because I'm actually configuring this DHCP pool for the data, I don't need to specify something called 150. right, so I will show you that configuration when I'm actually doing it on the voice. Let's go back to the DHCP pool for a voice now. This time around I will have to say IP DHCP pool, and then I'll just say voice underscore net. Okay, now remember we're trying to allow all of the voice devices to obtain the IP address automatically without us going to each and every phone and assigning the IP address to each and every one that is on the network. So in that case, I'm just gonna say 192.168.20.0 255.255.255.0, and then the default router is gonna be 20.1, and then we're gonna say the DNS server is gonna be 192.168.20.1, and then if we go to that configuration that I was actually talking about, we have to come here and select something called option 150 and assign the IP address of something called community manager express. So we're trying to allow the devices to actually register, or the voice device to actually register using that IP address of 192.168.20.1. In that case, I'm gonna do this. I'm gonna select the option, and then you will see I can use any number in between 0 up to 254, but I'm just gonna use 150. It's recommended to use 150, and then I have to specify the IP address of that CME, or Communication Manager Express. So we're gonna say 192.168.20.1. okay, and then we have to exit. All of our configuration is actually done here. Now, how do we make sure that there is no other device that takes our IP address? We have to come in here on a global config mode and say we wanna exclude the IP address IPDHCP excluded IP address, and then we have to specify that IP address. In that case, I'm gonna use that address, and then I'll also exclude this one. This ensure that there is no other device that can actually get listed with this IP address, because it is excluded from the pool. I hope that makes sense. Now we have actually configured the on-stick routing with the DHCP. Now it's time for us to configure something called Cisco IP phone configuration, which are these phones that I'm talking about. How do we actually ensure that they are actually getting the correct IP, and then they are also getting the correct directory numbers and so on. Now let's see how it looks like before the configuration, and then we're gonna also see the difference when it's configured correctly. Now I'm gonna switch it on first, and then you will see that the status is actually turning from red into green, as you can see. Now let's see the interface that is currently connected. This is the interface fast0/2. Now let me go back to it, and then I will navigate to the graphic user interface. What do you see here? It says it's still looking for the configuration. As you can see, I can't see any MAC address of this device, and then on the edge here on the right, top right, I can't see any number for it, or tailing number or something like that. So you will see the difference once everything is actually configured correctly as it's supposed to be. That way it's gonna start showing all of those details on the top. Now yeah, and let's go on this router and do the necessary configuration. Okay, first thing that you want to know, or that you want to actually allow, is something called telephone services. This is what you will need for our configuration. So all you have to do is, on that router that supports the voice, we have to type that command telephone services, and then if you go to this option, you will see that these are the most important option that we actually need for now. It's gonna be maximum ePhones, which defines the maximum number of IP phones that can be actually registered, and then this is the maximum directory numbers, the maximum extension number that can be used also. And then we're gonna select something called the IP source address with the port number 2000 in that case, and then we're gonna create CNA file. Right, now let's get on to it, and by starting by the maximum number of IP address that IP phones that we can use. So I'll select this command as it is. So it's gonna be max ePhones, and then let's see the range. It's gonna be 142. I'm just gonna use the highest range, let's say 42, and then from here I can go back to this one and say the maximum direction number that we can actually use. Let's see how many we can go up to. In that case, I'm just gonna use 20, but you can actually go this route itself support one up to 144. Okay, so after that, now we have to select the IP source. IP source address, and then we have to specify 20.1, and then we have to specify the port 2000. This is for our CME, and then let's press enter. Now once that we have actually done that, we have to define the directory numbers range to auto assignment. Alright, so let's do that. Auto assign 1 to let's say 20, and then let's create that file. Okay, let's create C and F files. Okay, it's complaining about the clock for the timestamp, but let's do this. Let's say NTP server, let's say 192.168.20.1. okay, now let's do something called show IP DHCP binding. This is gonna show us which devices are actually already being leased out with the IP addresses. As you can see, currently we have no devices being leased with any IP addresses. The reason why is because we haven't actually configured the switch to allow those VLANs to pass through the interfaces. So we still have to come to the switch, which is a layer 2 switch, and then make sure that we do the configuration correctly on those interfaces. Let's do that quickly without wasting time. All we have to do on the switch is go and type in enable, and then navigate to the config mode by typing the command config terminal. Right, now what do we know about the switch? We can see some cables connected to it. We know that we actually have a cable that comes from the router and is carrying the traffic that is not only native, or it's not only untagged traffic, but there is a tagged traffic. What do I mean by that? We have a VLAN 10, which is a tagged traffic, and then we have a VLAN 20, which is also a tagged traffic. Now, in order for us to ensure that both of the VLANs, or all of the VLANs, they're actually allowed on this interface, we have to change the state from being access and make it from a switch port access and mode. We have to change it into a trunk mode to allow multiple VLANs to pass through. How do we do that? We have to select the interface first by typing the command FA 0/1, and then from here we have to type the command switch port mode trunk. That's it. This actually says now this interface, especially that port, is allowing more than one VLANs. That's what it says. Now we can further prune the VLANs. To prune it means that there are VLANs that we can actually not allow, and then we can set an allowed VLANs to pass through. In that case, let me just manipulate it by only filtering into 3 for now. So I'll just come here and say switch port trunk allowed VLAN. It's just gonna be 10. Let me start from 1 just in case. It's gonna be 110, but I don't really need to allow 1, but let me just do it. It's gonna be 110 and then 20. Let's say you have a VLAN that starts from 40 up to 50, which means you want to allow VLAN 41 up to 50. Then you would have said 40 up to 50, and then let's say you also want to allow 60 alone, then 70, you would have done the same. Let's say you want to allow from 80 to 90, you would have said 80 to 90. That's how it would have worked, as you can see. Right, now let's exit from here and then type the command do show interface trunk. This will show us all of the interface that actually configured with this trunk. As you can see, there's only one interface currently on that switch, which is a trunk link. This is fast 0/1, and if you check in here, these are all the allowed VLANs on the trunk. Alright, now on the switch itself, if we type the command do show VLAN, we will be able to see that there is a native VLAN or the VLAN which allow all of the interfaces or all of the ports on the switch to belong to one VLAN, which is a native. We haven't actually created that VLAN 10 and also VLAN 20, so we have to make sure our switch is actually having that VLAN. We have to create those VLANs, which is VLAN 10, and then we can actually give it a name if we want to. In this case, we already know that this is going to be our data, so let's call it data, and then let's exit. Now if I do that command again, do show VLAN, I'll be able to see that now we have that VLAN being created, but there is no interface member of this VLAN, or there is no interface assigned to that VLAN. What we have to do now, we have to create another VLAN, which is VLAN 20, by typing the command VLAN 20 and then name it voice. Now if I do show VLAN, I'll be able to see that now we have two VLANs. The second one is actually voice, the first one is data, but the second one that we also created, it doesn't have any interface taken out from native VLAN and being part of voice VLAN. Alright, our objective is to ensure that these phones, they get the IP address which start by 192.168.20, and other devices that are connected to those phones, they actually get this range, which is 192.168.10.0.1.2.3, something like that, but it must be on the same subnet. That is what we are trying to achieve on this simple lab. Okay, we're gonna achieve that, and then also we want to allow ourselves to be able to call the phone that is actually here and call the phone that is here using the other phones that is on the other side, but technically all of these phones, they must be on the same VLAN. Alright, according to this lab. Okay, now that we have actually configured those trunk links, and also we have created our VLANs, we have to tell our interfaces to join or being the member of these VLANs, either VLAN 10 or 20. And on our configuration, we have to also remember that we have to allow switch port to access VLAN 10 and then switch port voice VLAN. Alright, let's do it quickly and see how it goes. So we firstly have to select our interfaces. Let's start by this one to ensure that we're doing the correct thing. This is 2, this is 3, there is 4, and then this is 5, all the way to 6, 7, 8, 9. Okay, we're gonna do it slowly, so let's go back to our switch. So from the switch, we know that we have to select interface. I'm gonna do it one by one. I'm not gonna use interface range in this time around, but you can actually do this by selecting all of the interfaces. I'm not gonna do that. I'm gonna do it one by one, so everyone will be able to see step by step. Now let's select the interface. Interface FA0/2. We wanna allow this port itself to be a switch port access. So we're gonna say switch port mode access, and then we wanna allow this port to be a member of the VLAN 10 by typing the command switch port access VLAN 10, and then also we wanna allow that this port, when it sees the traffic that's related to voice, it must assign that IP address of that range to a 4. So in that case, we have to type this command switch port voice, and then we have to specify the VLAN, which is 20. Alright, now about the spanning tree, as we all know that the spanning tree is a loop-free protocol, but that is for a different topic. And if you go up to one of the above videos, you'll be able to see that we actually highlight the basic configuration of the spanning tree, and we're explaining how it works, how the root bridge is being selected, and all of those. But for now, let's type in the command spanning tree. and then because this is an edge device, we have to say spanning tree port fast. Okay, and then this doesn't support this command, which is edge, so I'll have to leave it on a port fast. All right, this is the configuration that we have to do in all of the interfaces one by one. All right, now let me go to another interface and do the same thing. Interface FA 0/3 switch port mode access, switch port mode, switch port access VLAN 10, and then switch port voice VLAN 20, and then spanning tree port fast edge, but let me just type this one, and then let's say do right. Now let's do the same thing with other interfaces, which is 4 0/4 switch port mode access, switch port access VLAN 10, switch port voice VLAN 20, spanning tree port fast exit. Interface FA 0/5 switch port mode access, switch port access VLAN 10, switch port voice VLAN 20 exit, or let's say spanning tree port fast exit. Interface FA 0/6. I'm doing this one by one so that we all gonna be on the same page. And then switch port access VLAN 10, switch port voice VLAN 20, spanning tree port fast exit. All right, now let's go to, let's see which interface was this. This was 6. Let's go to 7, 8 and 9. Now I'm gonna select interface range FA 0/7 up to 9. I'm selecting all of those interfaces, so I'll do the same configuration once and for all in all of them. Switch port mode access, switch port access VLAN 10, switch port voice, it's gonna be VLAN 20, spanning tree port fast do right. So we've saved our configuration. Now we can actually say that we have successfully configured everything that the switch requires. Now all we have to do is to actually power our devices and see what is gonna happen. Well, it's not gonna work right now until we go back to a router and configure something else that is actually required. Config terminal. So from here, if we go to do show run, we can actually check how far with our configuration to see what did we do. We have actually excluded these IP addresses so that no other device will be able to take our IP addresses, and then also we have actually configured the DHCP pool for both data and voice traffic. And then if we scroll further more down, we can see that we have created the sub interfaces for .10 and then for .20. And then if we further go down about our phones, this is the information that we have actually created for our phones so far. There is one information that we actually need, in which we gonna need. This is the one that we actually gonna need. Configure ePhone phone lines, direct numbers. Now we actually trying to assign the phone numbers in all of these IP phones. All right, for example, if I call you on 062 whatever number, the traffic is actually routed toward that number. Now let's do the same thing here. So we have to type in that command, ephone. This is the command. I'll try to show you once more. Ephone direct numbers. So ephone dash direct numbers, and then here we have to specify we're gonna start from 101. Okay, wait, there's something wrong that we actually did. Let's start from, okay, sorry, this is phone number 1. Okay, and then this is the first phone, and then now we can actually specify the number by 1001. Now we're gonna do the same thing to all of them. As you can see, we have actually have that phone being registered with IP of 192.168.20.2, which is, this is the one, this is the phone that is currently on right now, which is already registered. As you can see, it has already got the IP address of that range of 20.0 network. So let's try to do the same thing to the rest of them, and then we also have not to forget that we still have to power on these devices as they are currently down. So I'm gonna do that right now, and if I click in here, you'll be able to see now that it actually shows us this detail. It shows us that this phone is 1001. If I can go to this phone, this one is still off, but I'm gonna try to power it on, and then you will see the difference that it's not gonna show so much of information because we haven't actually configured the secondary number that can be used. As you can see, there's nothing showing at the moment, but you will see as soon as I actually go to another one, ephone DN number 2. Right, now the second number that we are gonna have is 002. Now let's repeat and see. You will see now that the other phone will obviously have the same thing. Let's give it some time. You will see though. Let's go to exit, do right. I'm gonna try to, as you can see, this is what we have now. If I go back to that phone, as you can see, we have that number now showing in there, 1002, which is also showing some details on this side. Now let's go into here. I will do all of them one by one so that we're gonna be able to see. I'm not gonna try to bypass this by using a script. I'm just gonna use it, just gonna keep it simple. So I'm gonna do it again, ephone direct number 3. This is like a phone book, and then we are saying 1003 exit. I'm gonna do the same thing, number 4, and then I'm gonna say number 4 is gonna be 1004. I'm gonna do the same thing with number 5, and then on number 5 I'm gonna say number 1005. How many phones do we have again? We should have like 8. Okay, I'm gonna stop at 8. If you notice, all of these phones, they, after the configuration, they're not showing me any status of the IP address assignment. Why? Because they are actually still powered down, they are still off. So I will have to switch them on, and then we're gonna be able to see the changes occurring. So let's do it again. 46 number 1006 exit. Now let's do it over again for the second last. We're gonna say 1007, and then let's do phone direction number 8, which is the last one. The number is actually going to be 1008. Exit to right. We have successfully configured these topologies as a whole. There is nothing more that we actually have to configure. All we have to do now is to do our testing and see what are our current configuration on each device. Let's go back a bit to before I switch all of those devices. I want to show us what information is actually available on the other devices as well. I'm gonna try to go back to a switch. On our switch, let me go to the privilege mode. What I want to see here, I want to see the running configuration. I want to try to explain it over and over again. So what we have currently, we have this interface FA01, which is this one. We said because we have more than one network that we are actually trying to allow the pass through to the switch from the router, then we have to ensure that this interface port is having a different mode than access. It should have a trunk. There are actually 4 modes of the port. We have a dynamic auto, we have a disable, we have access, and then we have a trunk. And in this case, we're gonna use a trunk. As you can see, we have allowed these VLAN. Our intention was to allow 10 and 20, but then I was also trying to show you that we can select the VLAN ID uniquely, and then we can also select the range of those VLAN ID. This actually allows every VLAN ID which is between 40 and 50. This only allow one specific VLAN 60. This allow one specific 70. This allow from range of 80 to 90, which means 81, 82 up to 90. This is what it actually means, and this is a trunk again. Now let's check the other interfaces as well, which is 0 and 2. We have a switch port access VLAN 10, and we have actually said that this is what we want our devices, such as these computers here, to receive the IP address. They start with 192.168.10 dynamically from a DHCP server that we actually created. And then we also, on the same port, which is this one, we want to actually allow the devices like phones to actually get this range as soon as they are plugged on the same ports, but different IP addresses. One is for data, one is for voice. It means they will get this IP address, which means this phone will get the IP address which is on that network, and this PC, even though it's on the same port, but it will get actually different IP address of a different VLAN. Same thing applies on that interface, same thing applies over and over until this interface, which is 9. We didn't configure 10, 11, 12 because there is actually nothing plugged in there. Those interfaces are showing nothing because there is nothing there. Alright, now that is the configuration that we actually have in there on the switch. Remember, all the telephone service is going to be sitting on our router over there. Alright, now what else do we want to see? Show IP up. Here it's not going to show anything because there is no IP address which is attached to any MAC address on this switch. Alright, now let's go to the router itself and type in another command. Let's go to the privilege mode, and then we want to see something called IP DHCP binding. This is gonna show us the devices with their MAC addresses that are already assigned with these IP addresses. As you can see, for now we have 1 and 2. these are the devices that are actually assigned with the IP addresses of the voice network, because they are the only devices that are actually powered up. Right, the PCs, they are also powered up, but we didn't actually put the network interface card into the DHCP mode. As you can see, it's still on a static mode. But if I come in here and tell that device to allow to receive the IP client, or the client IP address from a DHCP server, then you will start to realize that it will get the IP address which is on a .10 range, which is this one. Now if I go to the router again and type in the same command, show DHCP binding, it will show me the dead device now. As you can see, this is showing me the dead device now, which is 192.168.10.2, which is matching the same IP address with this is a link local address, which is for IPv6, but this is the IP address, this is the default gateway, and this is a DNS server, which is the same thing applies here. It tells us that this is an DHCP. Right, what's gonna happen if I do the same thing on this PC? You will start to realize that the trend is actually common. This is gonna get a .3, and if I go back in there on the router itself and refresh this command, start to getting the fourth device now. We have 2 which belongs to voice VLAN, and then we have 2 which belongs to data VLAN. Alright, now let's go to this phone. We're just gonna simply plug in our phone, and then from there you will start to see that they are actually getting the correct numbers, and I'm gonna do it to all of them. I'm gonna do it to all of them, and then we're gonna go back to our router and see the status of registration. Okay, this is the power adapter. Alright, now before I actually go to the graphic user interface of these phones, I'm just gonna go to the router and see the status of the router itself. As you can see, I'm just gonna maximize this. It tells us that there is a phone that is actually get registered in there. It's got registered with the IP address. There is the other 5th phone which is also got registered. There are still more coming. So as you can see, we have another one as soon as it put it up, and we're gonna receive the last one now, which is gonna be I think .8 if I'm not mistaken. I don't know if it's gonna be .8 and .9, but I think there's gonna be another one. But all in all, it should be 8 phones, as we all know. Okay, as you can see, this should be the last one. Ever since our range start from 2 to 3, 2, 3 up to 9. We skipped 1. Remember, we said that we're gonna exclude that one because it's used as our communication manager express, and also it's sitting on our .1Q tech, and then all of these phones are actually being registered now, which means we can start to make our test by calling this is the router, how it looks like that we're actually configuring. So yeah, now let's start to make our calls and see the traffic being sent across. Now let's try to call. We actually know that we have said this is 101, so if I call this phone over here, so 101, 102, 103, 104, 105, 106, 107, 108. If I call 108, I am expecting to see only this device to ring, not this one, not that one, not that one, not that one. But let me tell you something, how we actually gonna see that on the device that is ringing, you will see it will flash these lights. The device that is receiving a call, it will tell us that there is someone who's calling from this number, and it will blink like this. And the other devices like phones, they won't be able to show anything. Now let's do that right now. We're trying to call 1008. Okay, you know those phones, you have to actually press OK, or you can do this. Okay, as you can see, it tells that it's going to 108. Now let's check if this is the one that is ringing. As you can see, this is not the one that is ringing. So let's go to this one. This is the 107 one. Let's go to the other one and see. This is actually the 108. As you can see, it's ringing. Now if I click here, it shows that it is being connected. It is receiving a call from 101, and hence that is why it was ringing and it was blinking. So the call can actually travel across. Let's use the same phone to call this phone, which is 107. I mean this phone, which is 107. This is the phone 107, and then we're gonna call using this one. Okay, now I'm gonna call from 108 and call in 107. 107 will have to tell us that it is receiving a call from 108. Now let's do that. 1007. Ever since we know that this is actually 107, this is 107, this is 108. Let's do it. It's ringing out using. Now if I come here, I can see it's blinking, and it tells me that there's a call coming from 1008. Click here, it shows me that there is a call now being connected. So these two phones now can actually communicate. There is voice traffic that can traverse through. Alright, let's do a call to 1003. 1003. I'm gonna ring it out, and then we're gonna check which one is gonna blink here, and then it's gonna tell us where is it receiving the call. Let's do it. This is 102. It's not this one. This is 103. If you look on the top corner, this is 103, and it's receiving the call from 107. As you can see, now it shows us that it is connected. So the phones are actually all working. As you can see, this is 105. I can actually call 101 from here. 101 is this one, so it is actually ringing, and then I can pick it up, and then the call is actually connected. So this is how exactly it's being done. I'm gonna try to close all of them. Okay, let me cancel. So this is how it's actually being done. Now let's check again on our router. I'm gonna try to navigate to the router and see if I type in show IP DHCP binding. Now what you will notice is that we still don't see much of 10 ranges, because the clients, they actually still sitting on statics. These devices, they are still sitting on statics until I go to each and every one of them and put them on the correct settings. This is the network interface card for each and every PC. So let's go in there. As you can see, now let's go in here. Okay, as you can see, let's do the same thing over here. As you can see, I'm not gonna select this one. I'm gonna leave it to a static IP, so that we will see that it won't show right now. All of them that I've actually enabled, they will show, except that one. Now let's do it over again. As you can see, these are the client of the DHCP. So we have the device that got 2, 3, 4, 5, 6, 7, but we don't have a device that got .8. Now let's make sure that device is actually part of the pool. As you can see, now we have added another device on the network which will get that IP address. Now if I come back in here and then go, as you can see, we have actually got another device which is joined the pool 192.168.10.8. now all of our DHCP pool is actually being populated. Now let's do a test from the command prompt to ping 192.168.10.8. as you can see, we can actually be able to ping the other devices. We can ping .7. Alright, we can ping .6. Alright, so this is actually how to configure these protocols, the on-stick routing, the DHCP, and the Cisco IP phones. Remember, we have said that we're gonna keep it very simple. This is needed for you to actually understand how the Cisco IP phone is being handled. Now you can obviously watch other videos which actually gonna encompass more stuff based on to this, but this is what you actually needed to keep you going. I hope this video was so informative to you. Let's meet again on the upcoming video.